Okay, multiplying complex numbers. So when we look at the imaginary number, so I equals the square root of -1. Naturally, I times I, that would get us -1, the square root of it, times the root of -1, and that equals -1. So, in other words, I squared equals -1. And that's what we're looking at here. So I squared times I squared would get us I to the power of 4, and that would be -1 times -1, which is +1, for example. So let's have a look at some questions. So I squared is -1. Express each of the following in the form a plus bi. So question 1. I squared becomes -1. -1 times -6 becomes +6. So the final answer is 12 plus 5i for that one there. Question 2. 5 minus 3i squared. When we square it, we multiply it by itself. I'm looking at double bracket here. 5 times 5 is 25. Minus 15i minus 15i. So that'll get us minus 30i. And minus 3i times minus 3i becomes 9i squared. But remember, with the I squared, it's going to leave us with -1. So meaning we are left with 25 minus 30i, and then 9 times -1 is -9. And that would leave us with 16 minus 30i. So both answers there. Okay. Determine the value of I cubed, I to the 4, I to the power of 101, and 3i o to the power of 5. So we looked at it earlier where, well, I cubed is I squared times I, and I squared is -1 times the square root of -1. So you're left with -i for that one there. I to the 4, I've shown it earlier, is I squared times I squared. -1 times -1, so that gets us +1. Now I to the 101, we're gonna be looking for a pattern here, essentially. So I to the 101, that equals I to the 100 times I. Well, I to the 100 is I to the 4 to the power of 25 times I. I to the 4 is 1, so 1 to the 25 times I. So it's +I in this case, so he's just left with I. Lastly, we've got 3i all raised to the 5. So 3 to the power of 5 would be 243 times I to the 5. Well, we know that I to the 4 is +1. So it would be 243 times 1 times I, leaving us with 243i. And there is the final answer. So next, now you can look at a test your understanding question. So I will pause that, and then next you'll look at exercise 1C in the book. So I'll pause this, people can have a go at it, and then naturally I'll look at the question. So z equals 2 minus 3i, so that z squared equals negative 5 minus 12i. So z squared equals, expand it out, you get 4 minus 12i plus 9i squared. So we 4 minus 9, you're left with minus 5 minus 12i, and we're done there. Expand 1 plus I cubed, well, we can look at Pascal's triangle here. So we're looking at this one here. So we're looking at 1 cubed. So 1 plus I cubed equals 1 cubed plus 1 squared times I times 3 plus 3 times 1 to the power of 1 times I squared plus 1 times I cubed, and you're left with 1 cubed is 1. 3 times 1 squared times I is just 3i. 3 times 1 times I squared would be minus 3. I'll fix that later when I collect like terms. And lastly, I cubed would be 1 times I cubed would be I squared, which is minus 1, so we minus I. And then we simplify that up. 1 minus 3 is minus 2. 3i minus I is plus 2i. And we are done there. So final answer, minus 2 plus 2i, minus 5 minus 12i. Great. Okay, so now you want to look at exercise 1C in the book, and I've left the challenge question. So I will look at that now. So we want to expand A plus BI, so part A. We expand it out. We're going to get A squared plus 2AB plus B squared I squared, and I can clean that up. So I squared becomes minus 1, so we're going to get A squared minus B squared plus 2AB. Okay. So part B is asking us to find the square root of 40 take away 42i. So we're going to use what we've just discovered here, and we're going to let 40 minus 42i, we're going to let that equal A squared minus B squared plus 2abi. Because when I square root this, I'm going to get it back in the form of A plus BI, and we're looking for the square root of this question here. Okay. So 40 is going to represent A squared minus B squared, and minus 42 will represent 2AB. So let's set up our simultaneous equations. So on the left hand side, we can say that negative 21 equals AB. And I'm going to go for negative 21 over A equals B. Therefore, B squared, well, we look at negative 21 times negative 21, we are going to get 441. So B squared equals 441 over A squared. So I'm going to use this, and I'm going to plug it in here. So 40 equals A squared, take away B squared, 441 all over A squared. So now I'm going to multiply everything by A squared. 40 A squared equals A to the 4 minus 441. I'll rearrange this. A to the 4 minus 40 A squared, take away 441 equals 0. We're going to look to factorize this. So a squared. 441, we're looking at, I think, 49 times 9. Yes, we've got minus 49 plus 9. So meaning, and we are told in the question, this is important now, they are positive integers. So when I go back to this question, we can say, well, we've got difference of squares here. So we can say a squared equals 49. So a equals plus or minus 7, but we're going to take plus 7 in this case. So we've got a as positive 7, and then we look at this here, or negative 21 over 7 equals negative 3. So b equals minus 3. So when we looked at it earlier and we said that 40 minus 42i, we can represent it as a plus bi. A is 7, b is minus 3. So the square root of this here equals the following, because the squared version gave us that. So the square root of it is the following, it equals 7 minus 3i, and there we are. Let's just double check that the answer works. So when we square it out, we are hoping to get 40 minus 42i. So let's have a look. 7 times 7 is 49. 7 times minus 3i, and then minus 3i times 7, you're going to get with minus 42i. And then minus 3i times minus 3i is positive 9i squared. But the I squared becomes minus 1, so it'll be 49 minus 9, which is 40 minus 42i, and it works. So the final answer is 7 minus 3i.